So I'll show you what that is in a second. We're going to use 2024 aluminum because it's lighter, although unlike steel and stainless steel, it can't be silver soldered, but it doesn't have to be silver soldered in this case, so we're going to use the 2024 aluminum. It's aircraft aluminum. Now we're going to do two joints in series. Here's a drawing of that we can screw them together and then drill a hole spaced exactly the same on the top and the bottom. This is our spacing here. You'll see how that works. We want to keep the two pieces of metal, the top and the bottom of the joint, together so that all the holes are parallel to one another and properly spaced. So let's take a look at one of these joints and see. Here's the joint, the double ball sandwich joint. It works beautifully. The first thing I'm going to do is I'm going to use a Sharpie to color this piece of metal good and black, so that I'm going to be able to see all the marks I put on it. I'm going to find the center point of this piece of metal, and I'm going to scribe a line down the center of the metal. Yeah, and now that we've got that, we'll measure our joints out here. Now they're 3/8 inch ball, so I know that the center of the ball will be 3/16 in from there. I further know that I have planned the center of the balls to be 9/16 apart. So 2, 4, 6, 8, 9/16 apart. I also know that the end of the joint will be 3/16 from there, because there's a 3/8 inch ball at that end too. 1, 2, 3. So I'm going to mark the end of the joint, and I'm going to lay out another joint right down here. I'm going to leave a kerf, it's called, where I'm going to cut it apart with the hacksaw. I want to leave extra there because I could always grind that off. Alright, now I have to make the mark for the screw that's going to go in between. It's going to go right in between these things. They're 9/16 apart. Therefore, it's going to be 9/32 in from the end. So I'll go around to the 9/32, or the 32nd side of the ruler, and measure 9/32 in from there. Yeah, you're going to have to learn how to use a ruler. 4, 8, 9, right? Yeah. Alright, so I'll lay out the second joint. Alright, now we got them all scratched. It's time to punch them. So, we're ready to drill some holes. Here's our piece of metal that we just marked up and made punch marks in. And here's another piece of metal that's exactly the same size. I'm going to screw these two pieces of metal together through the hole where the screw of the joint's going to go. And that's going to keep these pieces of metal flat, close together when I drill the holes for where the balls are going to go. And that means they'll all go through there parallel and I'll be lined up just right. Now the next trick is, how do you hold the metal down while you drill it? The simplest, most accessible way for most of us to get to attach the metal down when we're going to drill it. But the simplest way is to use a vise and a C-clamp. There's another way I'll show you that I like even better. This is another way you can attach the metal down to the drill press table. If you do the thing that I do, which does annoy my machinist friends when they see me do this, when I get a drill press, and I don't buy expensive ones, so I like this one an awful lot. It's an old one. I drill a hole right through the table, and I use that hole to drill all the subsequent holes I'm going to drill. Okay, we'll get that in there nice and tight. Now we're going to go straight through. Okay, here's our two pieces of metal we just drilled a hole in. I've taken them off the drill press table. We're going to cut threads with a tap into the bottom half we're going to make a bigger hole in the top half so the screw can slide through the top half and screw into the bottom half. Here's our tap handle, and our 440 tap is going to fit right in there. Tighten it down. Now, I want to go straight in. I'm going to have to press a little bit. Okay, I'm going to press down for a little while and go straight in. Now, this is a very brittle piece of metal, this tap. It's hard. It's made to cut threads, and it will cut the threads. I've got to go straight in order to avoid breaking the tap. I've got to press down and do a few turns until it catches. Yeah. We can screw these two pieces of metal together now. Tighten that up. Yeah. I'm going to cut the bottom, the long part of the screw off. Okay, now with these guys screwed together tightly, I'm going to drill the other screw hole in the center there and screw and do the same thing I did here, right here. Okay, there they are put together. I've done the same thing over here. Now it's screwed together in two places. It's good to do two of them together because it keeps everything in line from the top to the bottom. The next thing I'm going to do is drill 1/8 inch holes where all the ball holes are going to go. Okay, so what I've done now is I've drilled out 1/8 inch holes where all the balls are going to go. I've got some really important steps to tell you about here. First thing we're going to do is we're going to get a file that's got a sharp edge, and we're going to code the side with some scratches so these always go together right. The other thing I'm going to do is a very important step to do because it's going to decide what side we're going to make the sockets on. We want to make the sockets on the inside of this. Get this guy out of here. Alright, got my Sharpie here. I'm going to open it up like a sandwich. So I'm going to mark where the inside sockets are going to go for the balls. They're going to go there and there and there and there and there. I want to introduce you to what we're going to make the sockets with. These are Weldon 82-degree countersinks. This is much better than countersinks that have a lot of blades on it. This doesn't vibrate and shatter when you're making the socket. We've got our Weldon countersink in there. We've got a C-clamp to the table. Let's come a little closer so you can see the action a little better. Okay. And here we go. Now, I'm going to go in a ways. That looks a little happier. Okay, yeah, I like the way the ball fits in there now. So now I'm gonna cut these joints off the big piece. So now we'll clean up the ends and file them down and make them beautiful. We're just gonna file down the sharp edges now, and I'm gonna go all around this thing. Make it beautiful. See, we'll put a barbell on that side. We'll put a barbell on. This is the one we just made. Alright, so let's screw it down. See if we've made a joint that works well. Because sometimes they do and sometimes they don't. That's why it's good to make two of them at a time in case one of them doesn't work, maybe the other one will. And this one seems like it's working real well. See our coded marks, and tighten it down a little more. Well, that's a nice joint. Today we're going to build the thigh portion of this leg. Now notice that in this part up here we want the joint going this way. So we're going to make this out of steel because I'm actually going to twist the steel, and I'll show you how I'm going to do it. Get this joint going here and this joint going here. We're going to make it out of steel because steel twists better than aluminum. This is made out of steel, and these are made like the double one we made, except that this piece of metal is bent. The principle is instead of having a ball at one end, at the far end, we have this bent over piece of metal. Okay, so first we're going to cover up the metal with the Sharpie. Scribe the line on there. Transfer the measurement. Boom. Punch some of these marks. So then we drill our 2 screw holes. Having my beautiful safety glasses on. Get some lubricant on there because it's steel and straight and steady with that tap. Drilled and tapped, both holes are screwed together. Now we're ready to drill the sockets. With the joints coated on the side, we'll take it apart like a sandwich and mark where the sockets are going to go. We want to bend this over to an L angle. The leg twisted, we now have the hip and the knee oriented properly to one another, and it works fine. When a puppet puts his foot down, it has to be attached down to the stage firmly so that he can support his weight and stay there. The way that's done is with a piece of metal like this with a hole drilled in it, silver soldered to a ball. The hole is threaded so that a screw will go in the hole like that and thread in there tightly, and then this is tightened down to the stage like that with the wing nut. I'm going to clean all this up with sandpaper, make sure it's good and clean. Clean metal there so that it can flow. And I'm going to put white out on part of it to keep the solder from flowing where I don't want it to flow. I don't want it to go in there. So we'll let that dry. Clean that off. Put that here. This guy's set up in the right place there. I have put the foot that we just made into where it'll go here, and that's where actually the puppet's hoof comes off of. So it works just fine there. And the way this is going to work is when we want to attach the foot down to the hole, we're going to put the foot down over the hole. Then we're going to thread this up into this threaded part here in the foot, and then we'll tighten this down. The stage will be right here, and that way the puppet's foot will be pulled down by this wing nut. Will be pulled down hard to the stage, and it'll stay there. All right, now this foot here we just made has a hole threaded to receive the screw to tie the puppet down. This one over here is slotted. It doesn't have a hole, it's got a slot in it. We're going to use that slot. I like this system better. I'll show you how it works. We put the slotted foot over the hole in the stage. We put the T part of the tie down up through the hole, and then a quarter turn, and then you tighten this. We turn that and we tighten it. We tie that foot down securely to the stage, and when we've made it nice and tight, that foot is not going anywhere. You have to come up with one of these. Now all this is a T shape that I made, a little anchor shape that I silver soldered together out of rod, and that's silver soldered onto a 1/4 inch thread here, 1/4 20 thread. Then I got a drawer handle, and I stuck a blind nut or a T-nut that's also 1/4 20 on the back of that. They're called blind nuts or T-nuts, depending on who you ask. And I silver soldered this handle on the bottom of it. You can see this is just a bolt, really. And notice that the handle goes in the same direction as a T up here. So when I stick it through and I turn it, I know that it's secure in the foot. Today we're going to look at making architectural shapes for the puppet, the skull and the chest. What these are made out of wire, and they're just a shape inside the puppet, so when you squeeze the chest or the head, you can grab a hold of something and move the head. We're going to be working with 3 different sizes of wire. This is 1/16, 3/32, and 1/8. Here on the plans you can see the skull that I plan to build, and this is built out. This is a wire shape. This is a side view and a front view, and I basically drawn it about 1/8 inch size wire, but I might make it out of thinner wire. So first thing I'm going to do is